Hey guys, happy Friday to all of you. Thank you so much for being on today as we go over our weekly Free View Friday, where we provide step by step detailed solutions to our ACT questions that we release every week in the free Facebook group. And so every Friday, an ACT certified educator goes over those sample true official released from real test those questions. We go over them every Friday in the group, and today yours truly, Miss Tori, I'm going to be going over them. This week we dealt with science, so there's 4 science questions we're going to talk about today. But guys, as you come in, would you please drop where you're viewing from in the chat, in the comments below? Let me know what city, state you are tuning in from. If you're catching the replay, drop hashtag replay in the comments. And guys, if you have any goals, anything you're trying to accomplish in terms of ACT, a certain score, or if you're working towards qualifying for a scholarship, let me know in the comments what your goals are, and we'll be happy to follow up with you and help you kind of reach those goals. But yeah, I'm here live today, coming in on my personal page because I promised you guys that I was going to do a live training, and I am very soon. I appreciate the feedback that you guys shared. As a matter of fact, let me get some feedback on that too. Now, for those of you watching, you'll know that these are coming up, and you can let me know which ones you want to see as well. This is what we kind of got. So I gave you guys some options. We're going to do how to get an official ACT test with an answer key. How can you cop an official test that they actually released, test that they took on a Saturday morning? How can you get a copy of that test with an answer key? We're going to talk about that. Another training is how can you score in the top 10%? How can you get a score of a 30 or higher so you can definitely be qualified for scholarships and attend college debt-free? And another option was how can you analyze your ACT score results and determine like where should you really focus? Where do you need to kind of put all of your efforts and attention in order to increase your score? So if you guys want to drop a 1, 2, or 3 in the comments below right now too, just to see kind of if the vote changes a little bit. Right now, number 2 is in the lead, but not by much, just a little bit. But a lot of people did comment all 3. So make sure you're back here Wednesday coming up. I think that's July 20th. My mom's birthday. If you'll be here on Wednesday, then I'm going to definitely do a training on number 2, how to score in the top 10%. So make sure you're back for that. But drop that in the comments, 1, 2, or 3, and then I'll know which one is going to be next, if it's going to be topic 1 or topic 3. But guys, we're going to go ahead and get into the Free View Friday, review those 4 science questions from this past week. So let me just get those. All right, let me know, guys, is this coming through okay? If you can see it, drop some stars in the chat so I'll know that these questions are showing up for you. Let me know. Okay, good. I'm glad everything is showing up and you guys can see. I've got to make this a little bit bigger. We're not going to be able to show all of it at the same time, but you'll see here, these questions did come from a released ACT test, science test. We're looking at passage 6, and we're looking at these 4 questions. Now, when we go over this, I like to let you guys know the strategies that you should use, just like if it was test day. And so I can see here, I've got a science passage with several paragraphs. There's some chemical equations, looks like a figure, and all of that might look intimidating, but that's okay. We're going to bypass all of that and go directly to the questions. Because we remember on the science test, the question is going to direct us to the answer 9 times out of 10. So we're going to go ahead to question 34. It says, based on the description of the demonstration. And then there's a comma, which lets me know I need to pause. And if I just break down that little bit, it is giving me the directions of where I need to go. Based on the description of the demonstration. That means I need to find the paragraph about the demonstration. That's where my answer is going to be. So I don't need to be concerned right now about student 1, student 2, student 3, the figure, student 4, any of that. If I read that first, I would have wasted a tremendous amount of time because the question tells me in that first phrase, just look at the demonstration. That's it. Okay. So now I know where I need to focus my attention. I can find out what the rest of the question is asking. It says, were the bubbles that formed more dense than the surrounding water or less dense than the surrounding water? Now, if I ignore the answer choices right now, it sounds like my question is asking me one or the other. It's like a 50-50 chance. Is it more dense or less dense? That's what I need to determine from the paragraph. Okay, so I'm just going to stay right there for now. We'll go a little further in a little bit when we come back to the answer choices. But basically right now, I'm trying to determine, are these bubbles in this paragraph more dense or less dense? So now look here, it says a science teacher poured 400 milliliters of water into a beaker and heated the beaker with a Bunsen burner. After a few minutes, bubbles began to form in the water and float to the surface. 4 students were asked to explain how the bubbles were formed and also to describe the composition of the bubbles. Going back to the question, it says, were the bubbles that formed more dense than the water or less dense than the water? Okay, it says the bubbles began to form and then float to the surface. Now, you don't have to have too much scientific knowledge, but now let's think about this. If the bubbles are formed and they float to the top, floating up, would that be more dense or less dense? If it's floating, that's kind of like, think about in air. If you blow up a balloon and the balloon floats, is that less dense than a rock, or more dense? It's floating, right? So you probably can pick that it's less dense, which means you can now eliminate all the answer choices that say more because you know it's less dense. So let's just scratch those incorrect answer choices out. Okay, so F, G are gone. Okay, we know it's less dense, so it has to be H or J. Now you just need to select the correct explanation as to why it's less dense. Well, why did you pick less dense? Because it floated to the surface. So let's find the answer choices, the answer choice that matches. H says bubbles sank to the bottom. That's not what happened in the demonstration. So that's incorrect. J is the right answer. Less dense, the bubbles floated to the surface after formation. Okay, hopefully that makes sense, guys. If you participated this week and you got J, congratulations. I'm glad you guys got that one correct. If you didn't get that one right, then hopefully you understand why at this point. All right, let's move on to question 35. So question 35 says, during the demonstration, bubbles were observed to form well below the water surface. This information directly contradicts the explanation given by which student? So the question is telling you that you need to go to the students' reports, to their paragraphs, and find out which student has something in their report that is opposite, that contradicts what the demonstration said, which was that the bubbles were observed well below the water surface. So you want the opposite of that. Okay, so you got to go read what the student said and determine which one is saying something contradictory or opposite to what was in the demonstration. So we can glance back here. And you guys, you can put your answers in the chat. You want to kind of do them as we go. And then as I get to the explanation, you can check yourself and see if you got it right. So drop those in as we go through if you think that's A, B, C, or D. Okay, so student one, the chemical form, and I'm going to kind of read through this a little bit. The chemical formula of water is H2O. As H2O is heated, the chemical bonds between the hydrogen and oxygen atoms break, leaving individual hydrogen and oxygen atoms. The hydrogen atoms dissolve in the remaining water, while the oxygen atoms combine to form oxygen molecules. The breakdown of water and the formation of O2 can be summarized by the following chemical equation. All that's fine. We need to know about the bubbles. Because O2 is a gas, it forms bubbles in the water, and the bubbles contain O2 only. Okay, so we're trying to find a contradiction. Remember, the demonstration says the bubbles were formed well below the water's surface. We're looking for something opposite that. Student one says bubbles are formed in the water. That's not necessarily a contradiction. Let's just keep going and see what all the students say and see if there's an obvious student that is contradicting the demonstration. Student two says student one is correct about how the chemical bonds in H2O break down and how O2 molecules are formed. However, the hydrogen atoms do not dissolve in the remaining water. Rather, they combine, blah, blah, blah. We're getting to the bubbles. Because both O2 and H2 are gases, bubbles are formed in the water, again, in the water, and the bubbles contain a mixture of O2 and H2 only. Okay, those kind of sound the same. In the water, below the water surface, that's in the water, same thing. All right, let's look at student three. The chemical bonds in water do not break when water is heated. We still need to get to the bubbles, right? Let's see if I can skip around a bit. As more and more hydrogen bonds form, a thin circular sheet of hydrogen bonded water molecules formed. When this sheet comes in contact with the surface of the water, air pressure pushes down on the center of the sheet, causing it to bow in the middle and close up on itself. Okay, that's the creation of the bubble. The bubbles contain a mixture of gases only. Okay, let's see. Any more for that one? So the bonds do not break, water molecules, thin circular sheet. Okay, when this sheet comes in contact with the surface of the water. Okay, so this one is up at the surface. Air pressure pushes down. And so this is more up at the surface. Okay, for student three. Let's look at student four. As the water is heated, chemical bonds are neither broken nor formed. Instead, the water molecules absorb the heat energy, and this energy is converted into kinetic. Once the kinetic energy reaches a certain threshold, the water begins to change from liquid phase to gas phase, forming bubbles that contain water vapor only. So when this one says, once the kinetic energy reaches a certain threshold, the water begins to change from liquid to gas, forming bubbles that contain water vapor only. Okay. So if we kind of think through that, we're looking for one that contradicts the fact that these bubbles are absorbed well below the water's surface. Okay, so which one of those, if you kind of think through, like 1 and 2, we know are not in contradiction. They're obviously, we can see like reading right off of it that the bubbles are formed inside the water. So you really narrowed it down between 3 and 4. Which one seems to be most in contradiction? And so that's going to be student 3, which is C. because this one is saying that it's up at the surface of the water. And we notice in the question that it's well below the water surface. So we're going to go with student 3 as being directly contradicting, right? Like directly contradicting. We're talking about surface and where the water bubble is. And this one talks about the surface and the other ones don't mention the surface. So that's the direct contradiction. Okay. All right. So I hope that's clear. Moving on. Question 36. Which students stated or implied that the bubbles contain gas molecules? Okay, so again, it's directing you where you need to go. You got to go through the students' responses. But which students stated, like just flat out said it, or implied that the bubbles contain molecules? So gas molecules. So if you look at student 1, excuse me, we got H2O, hydrogen, oxygen, and it says it's going to form O2, and O2 is a gas. Okay. So definitely student 1 is implying this or flat out stating it, but student 1 does talk about gas molecules. So that means we can immediately get rid of answer choice G and H from the problem because they leave out student 1. And student 1 clearly stated or implied that there is gas. Okay. Student 2 also has O2 in the situation, but they have H2 as well, says those are gases and they have to do with the bubbles as well. So we have student 1 and 2 for sure. Okay, so at this point, we can't get rid of anything. No more answer choices. We're still stuck between F and J. Okay, let's move on to student 3. The chemical bonds in water do not break. They're called hydrogen bonds. It's more and more hydrogen bonds. A thin sheet comes over. Okay, the bubbles contain air, which is a mixture of gases. So there you go. It's stated that there are gases. So student 3 does it too. So now that means I have to rule out answer choice F because I know already 1, 2, and 3 have stated or implied that there are gas molecules in the bubbles. So that leaves me with J. I don't need to waste my time reading student 4 because J is the only option left. So that is our answer. Hopefully you guys got that right. Let me know. Are you guys getting them correct? Are you understanding the explanations? I hope so. Yeah. I guess before we move into the last question, just want to remind you that we do offer this every week, every Friday. I'm kind of giving you guys a sneak peek today live on my page and also in the group, but we do this every week in the group. We rotate out. So some Fridays we do English questions, some Fridays it's math, some is reading, some of course is science like today, but we do this every week. The questions come out every Monday. You can do a question every day and participate with us. And then on Friday, come right back here so you can check your work and get step-by-step solutions and strategies. So guys, hopefully you are taking advantage of that, especially those of you who will be taking the test tomorrow. Now there's a big ACT test tomorrow, and some of you really need this last shot to qualify for some major scholarships. So we wish you all the best. But yeah, guys, I just wanted to invite you to join the group if you have not already. If you need that link, just type the word group in the comments and I'll make sure that I get that link to you. But yes, definitely come in to the group so that you can take advantage of all of the ACT prep resources that we have available. And so that's Fridays. On Fridays, we do the review of the questions. But on Wednesday, we talk more about prep in general what are some of the best strategies? How can you get this score? We talk about scholarships. We talk about college admission. So definitely make sure you take advantage of the Wednesday evening trainings as well. And like I said, this Wednesday, July 20th, I'll be here on my page again as well. And we're going to talk about how to earn a top 10% score, 30 plus. So with that, make sure you drop the word group in the comments so we can get you in. All right, last question, guys. Last question, number 37. It says, according to students 1, 2, and 3, so once again, telling you where to go, the process of bubble formation in water involves which of the following changes? So we're only looking for bubble formation in water, and we're only looking at students 1, 2, and 3. And it needs to be in common, right? How are bubbles formed in water? Which of the following things change? So let's go through and see about how the bubbles are formed. Student 1, bubbles begin to form in the water and float to the surface. So the water in the beaker is heated. After a few minutes, bubbles begin to form in the water and float to the surface. Oh, I'm sorry, I'm reading the demonstration. See what happens when you don't go where you're supposed to go? So there's a real live example. I'm like, that didn't make sense. You know why? Because I did not go where I was directed. It directed me to student 1, where I should have gone, not to demonstration. And now I wasted time, right? If this was a real test, I just wasted significant time reading the demonstration. So life lesson. All right, we're looking at student 1. The chemical bonds between hydrogen and oxygen here. Atoms break, leaving individual hydrogen and oxygen atoms. We want to talk about bubbles. The breakdown of water and the formation of O2 can be, here's a chemical equation. Okay, because O2 is a gas, it forms bubbles in the water, and the bubbles contain O2 only. So we have a combination here. Okay, we have where the hydrogen is dissolving in the remaining water. Okay, got that. All right, let's look at student 2. They are correct about the chemical bonds breakdown and how O2 molecules are formed. However, hydrogen atoms do not dissolve. Then let's go to student 3. Chemical bonds in the water do not break when water is heated. Instead, water molecules form new chemical bonds called hydrogen with other water molecules, and more hydrogen bonds are formed. Okay, so what are we getting here? We're getting something about chemical bonds in our answer, but nothing about kinetic energy. So we can get rid of that. That's not the case. So we know it has something to do with chemical bonds, but are the bonds being formed or are the bonds broken is what we have to determine between these 3 students. What causes the bubble formation? Is it the bonds being broken or the bonds being formed? If we go back and do a final check here of what the students have said to determine if the chemical bonds are formed or if they are broken, we can see that we have here student 3, more and more hydrogen bonds form. A thin circular sheet of hydrogen bonded water molecules is formed, right? And that's what's causing the bubbles, right? Because it says that sheet chemical bonds are formed. And then from that sheet, we get the bubbles. That's what we get in this student 3 without me having to underline all of that, right? When the sheet comes in contact with the surface of the water, it folds up on itself and creates a bubble. So this one is going to be a chemical bond is formed. If we look up at student 2, we get However, the hydrogen atoms do not dissolve and they remain in water. Rather, they combine to form, right, H2. Because O2 and H2 are gases, bubbles are formed. They contain a mixture here. Those are two different chemicals, right, that are bonding together. Mixture of two different chemicals formed. All right, let's go back up here. Every time I scroll, it moves my highlighting, guys. I apologize. So I'm just going to clear it. But now I'm looking at student 1. Okay. And for this one too, the breakdown of the water and the formation of O2 can be summarized by these chemical equations. Okay. O2 comes from two oxygens. It's a chemical bond coming together to form bubbles in the water. So all of these are chemical bonds being formed, not chemical bonds being broken. Okay, so this is going to be A for 37 if you look at student 1, 2, and 3. Okay, guys. So just so you have the correct answers, 37 was A, 36 was J, 35 was C, and 34 was J. Okay, so check your answers. Hopefully you got those right and you understand why those are the correct answers. And if you answered incorrectly, then you understand where the mistake lied. So hopefully this has been helpful for you guys. Let me know in the chat if it is, and if you would like us to keep doing this. Also, I do want to point out to you guys the type of questions these were. All 4 of these questions were the same type, and they were here. 34, 35, 36, 37 right there. Okay, and you will see that these are EMI, or evaluation of models, inferences, and experimental results. Those are these type of questions. You can expect to see 10 to 12 of them on every ACT exam. So they're a good bit of it, about 25% of the test. You can expect to be these type of questions, but all 4 of them do fit for the evaluation of models. Okay. Thank you guys for being on today. I really appreciate you watching. And like I said, make sure you drop the word group below. We'll get that link to you so that you can join us on Wednesdays and Fridays for more ACT prep live trainings. I hope you all have a wonderful weekend. Good luck to all of you who are taking the test.